Hi, welcome to a new session of circuits and networks. In today's class, we are going to solve circuits and networks problems which have come in GATE 2026 in electrical engineering paper. So here I have shown two different circuits where the questions were asked in different ways. So we'll start with the problem. So in the first circuit, you can see we need to find out Thevenin's voltage and Thevenin's resistance across this AV terminal. So here 10 kilo ohms is there. So whenever you want to calculate the open circuit voltage, we have to remove the load. And when the load is removed, this is how the network looks like. And here we need to calculate the Thevenin's voltage and Thevenin's resistance. So for that, I have taken plus and minus randomly with VTH as open circuit voltage. And that is the voltage which is measured between these two terminals where the AB is taken. Now you see we have 100 volts and we have 20 volts, then we have 20 volts on the left hand side also. So 20 is connected parallel to 10k. So in fact this 20 is present over this 10k. Then you can see this 20 in negative form, it is applied across this 1 kilo ohm. So if at all I take the KVL in the loop, I can get the total voltage of open circuit as, you can see I have taken minus 100 here, then minus 20 is replicated as it is here over here, plus minus voltage terminals I have taken in my convention way, and on the flip side we have minus 20 and that is equated to 0. So here if at all you take the terminals voltage, it will be coming around 140 volts. Now the same open terminal, when I am going to replace with the resistance and I have to short circuit the voltage sources, this is how the circuit looks like. So you can see R Thevenin is obtained by short circuiting the voltage source. So this 20, when it is shorted, the 10 kilo ohms, it is taken care by this short circuit line, and that line will come over here. Similarly, when 100 volts is shorted, that is going to give a zero value of voltage across 10k. So hence on the right hand side and the left hand side, by looking into this particular network, we are going to get the resistance value as 0 because the voltages are replaced by short wires. Hence the current is going to flow in this short wire compared to the resistance. In resistance, the parameter is overshadowed by the short circuit. So hence the overall resistance of this particular uh, circuit, when you are looking through terminals AB, is 0. So the Thevenin's resistance is 0 ohms here. Now another problem, you can see a source voltage Vs of t, which is given as 325 sine 100 pi t volts, and the current is obtained to be 12 sine 100 pi t plus 9 sine 300 pi t amperes. What is the value of input power factor? So the questions are framed in different way, but for the easy understanding, I have reframed the question in this fashion. So you from here, the voltage, you can calculate the RMS value, which is nothing but 325 divided by root 2. So 230 volts is the value of the RMS voltage. 325 is the maximum voltage, and to get the RMS value, we have to divide it by root 2. Then compare this current equation. You can see in this current equation, we have 100 pi t and 300 pi t. This indicates what? The current source is having a fundamental component and third harmonic component. Now power factor is derived from electrical power formula. It is denoted by cos theta and it is defined as the ratio of the active power to the apparent power. So for that I have to calculate the RMS value of the current. So that is for fundamental value, it is given as 12 divided by root 2, which is nothing but 8.48 amperes. Similarly, third harmonic, it is given by 9 by root 2, which is 6.36 amperes. So overall RMS value is obtained to be under root of this R1 RMS value and R3 RMS value square root. That value is 10.606 amperes. So once this is done, I can calculate the active power, which is given by Vrms I1 RMS value, that is 325 by root 2 multiplied with 12 by root 2, which will be obtained as 1950 watts. Similarly, the apparent power is given by Vrms and IRMS, this actual value. So that value is obtained to be 2437.5 watts. Now when you talk about the power factor, it is nothing but the ratio of the uh, active power by the apparent power, which is obtained here to be 0.8. So the value of power factor is 0.8. In the third problem, we have to find out the load resistance for maximum power transfer condition. So here we have to find out load condition. So we'll remove the load resistance and we are going to short circuit the voltage source because we require only the load resistance value, and the maximum power is transferred only when the load resistance is equal to the source resistance. So when this is shorted, the 5 ohms is taken care by this short wire. In fact, 10 will be parallel with 4 and the load resistance value is equal to 2.857 ohms. So I must say this time the GATE electrical paper, in this circuits they have framed a very easy type of questions. In the next question, we have to find the average power for V is equal to Vm sin omega t and I is equal to Im sin omega t minus theta over half cycle. So the power formula is given by V into I. Just given values are substituted here. Since we have here sin A multiplied with sin B, I can replace the formula with the help of sin A sin B formula, and that is obtained to be Vm Im by 2 cos theta minus cos 2 omega t minus theta. Now this is the harmonic component. It can be neglected. We have to take only the true power. So when the average power is accounted for half cycle, the value of integration of cos theta will be sin theta, and sin 0 or sin pi value is always 0. So the average power here it is obtained to be 0. In the next problem, we have to find out the Norton's current and Norton's resistance for the network shown with the values of Vx and Ix, which is given in this problem like this. So we need to find out the current and resistance. For that, we are going to take the help of the two-port concept. So this two-port I am replacing with by voltage, Thevenin's voltage in series with Thevenin's resistance, and one current which is flowing is taken as 0.5 amperes with 30 volts. Okay. Another circuit I can take with the same current conditions, which is changed to 1 ampere and 36 volts as the changed value of voltage. The equivalent resistance and in series with Thevenin's resistance are kept as it is. That is the same thing. Now take the generalized equation for VTH, RTH and IX is equal to 30 for this particular circuit. And when I substitute the value of current, I'm getting the equation as 1. Similarly, looking into this circuit, I can frame another equation as 2. Now with this, I can get the value of RTH, which is nothing but 12 ohms. Once 12 ohms is obtained, I can make use of equation 1 and equation 2 to get the value of open circuit voltage, which is here obtained to be 24 volts. Once voltage is obtained and resistance is obtained, it is easy to calculate the current, which is nothing but open circuit voltage by resistance. So the value is here, it is 2 amperes. So resistance value is 12 ohms and current is 2 amperes. So this is how the questions are framed for electrical paper in GATE 2026. There are some more problems which I'm going to solve in the next session. I will include also the EC paper where the network and the circuit problems are frequently they have asked, and we'll discuss in the topic in the next class. I hope you like this video. Please share among your friends and subscribe to this channel and press the bell icon for the future notifications. Thank you.